Welcome back, students. Now this is our last part, electrochemical cell and electrochemical series, and this is very important part because you will see the application of this part of redox reaction in the chapter of electrochemistry as well in class 12, electrochemistry as well. So that's why this part is very helpful in making your concept very easy at that time when you will be studying the electrochemistry chapter. So that's why you have to listen to me very carefully in this chapter. Here we go. So hi students, this is our last part, electrochemical cells and electrochemical series. And why this part is important, because this is totally the application of redox reactions in electrochemistry. So that we'll deal with. So electrochemical cells, these are of two types, galvanic and electrolytic. What are galvanic cells? Galvanic cells, it converts your chemical potential energy into the electrical potential energy to perform work. Then we get the energy and we get electricity. And electrolytic cell, it uses electrical energy to drive that cell and to happen the chemical reaction in that. So they are totally the reverse cases of each other. Okay. Now redox reaction in electrochemistry, why I'm saying is the application because of oxidation and the reduction taking place. Okay, oxidation and the reduction taking place. Oxidation is what? Where my loss of electron is taking place, which is anode, and reduction where my gain of electron takes place, that is my cathode. So you can remember this thing by this word also, lone. Left oxidation, anode negative. Okay. So many electrochemical processes, they are used commercially for production of pure metals, like aluminum manufacture by electrolysis of Al2O3, magnesium manufacture, electrolysis of MgCl2, sodium manufacture by electrolysis of sodium chloride, the common salt. And EMF of any cell, that is equal to oxidation potential plus the reduction potential. Okay. And this should come positive, then only we will say that the cell is spontaneous from equilibrium, from thermodynamics. Okay. Now this is the electrolysis of Al2O3. Okay. So Al2O3 is dissolved in molten cryolite. Cryolite is Na3AlF6, and this is how we obtain the Al from it. Al2O3 plus 3C, these are the graphite anodes. Okay, this reaction is again a redox reaction, because this is what getting reduced, this is getting oxidized. So it is a redox reaction, and this is the application of redox reaction where I am obtaining aluminum from Al2O3. Okay, from Al2O3. Next is electrochemical series, guys. So electrochemical series tells us about the reduction potential of every element. So it is actually a total series, a table, okay, which tells us what is the reduction potentials, and also tells about the tendency to reduce other metals or non-metals. Means the one which will be low in the list are able to reduce the above ones. The one which is having more negative reduction potential may reduce the above ones, but the reverse is not true. So you can come to know that which can replace or displace the other elements, means which will follow the displacement reactions. So this will help you know the questions which ask displacement reactions. So the higher the negative value, the higher the capacity to reduce. And in the table below, which have been negative reduction potential, can reduce the upper ones. Means the lower one will reduce the upper ones. So this is the table, guys, of reduction potential, means electrochemical series you can see. And you can see here, if I just highlight, this is the position where my hydrogen comes. Okay, this is the position my hydrogen comes. So your Cu2 plus is above that. So in most of the time, you have to remember this thing that copper cannot replace hydrogen. Okay, from any salt. Also, question of Fe3 plus and Fe2 plus comes in mind. So Fe2 plus replaces, this zinc, or say whatever is above it. Okay, not zinc. Fe2 plus will replace the above ones, so hydrogen, but Fe3 plus will not. Also, here I have Zn2 plus, here I have Cu2 plus. So that means Zn2 plus will replace the Cu2 plus. That's why you have one equation, if you remember, that Zn plus CuSO4 gives you ZnSO4 plus Cu. Okay, so that is why, because of the reduction potential of zinc is more negative as compared to your Cu2 plus. Okay, you can see that. So this you will apply, and also you can you will be asked to calculate, say suppose the EMF of any cell. So that is E oxidation plus E reduction. In that way you will calculate. So I write E cell, so that is equal to E oxidation plus E reduction. So this is how you calculate the EMF of any cell. So your data will be given and you have to just apply it. Okay. Hey students, so we discussed the types of electrochemical cells. Okay. We also discussed how electrolysis is performed. Also, I've shown you the chart of electrochemical series, which will tell you that which element can displace the which one. So we saw that the one which is having more negative reaction potential can replace the above ones, means the ones which have less negative reaction potential. Now this was our last part, okay, of this redox reaction whole chapter. Now the time has come that as you have well through the whole concept of redox reactions, so we will be better doing the practice of some question, and that question will be very important because they are JEE question. So stay tuned with me for the next part, which is the JEE question round. Okay, JEE question part.